Welcome to part 2 of our right triangle trigonometry review. We're going to look at special right triangles now. The first special right triangle we're going to look at is the isosceles right triangle. If you recall from geometry, an isosceles triangle has two sides that are the same. We also know that angles opposite congruent sides must be congruent, and we have 90 degrees tied up in making this a right triangle, so the other two angles are 45-degree angles. Since we are working towards our unit circle, I am going to consider a hypotenuse unit length of 1 for our review purposes with special right triangles. We're also going to use our Pythagorean theorem then to find the length of our other two sides. I'm going to call them both A because they are the same. And if I made one A and one B, then I'd have to say that A is equal to B and have another step in setting up my Pythagorean theorem. So the square of each of the two legs added together is equal to the square of the hypotenuse, the length of the hypotenuse, which is 1. 1 squared, of course, is 1. And A squared plus A squared is 2A squared. So now I have 2A squared is equal to 1. I'm going to divide both sides here by 2. I have A squared is equal to 1/2. So now I'm going to take the square root of both sides. And that gives me A is equal to the square root of 1 over the square root of 2, which gives me 1 over the square root of 2. Now remember that we don't like to leave radicals in the denominator, so we are going to rationalize this by multiplying by 1 in the form of the square root of 2 divided by the square root of 2. The square root of 2 times the square root of 2 is just 2, and 1 times the square root of 2 is the square root of 2. So I get side lengths here of the square root of 2 divided by 2 for each of these two sides for this special right triangle when my hypotenuse length is 1. Now, of course, if I had a variable in here, it could be x, then I would have lengths of x for the hypotenuse and the square root of 2 times x all divided by 2 as the length of each side. Because again, similar right triangles, I can just scale this up or down. Let's go to our next special right. Our next special right triangle is just called the 30, 60, 90 right triangle because those are the angle measures. You might wonder why we are looking at an equilateral triangle when we're talking about a special right triangle. Well, we're going to derive this right triangle from our equilateral triangle. Since all the sides are the same by definition in an equilateral triangle, all of the angles are the same. The sum of the angles in a triangle is 180. So if we divide the sum of 180 by 3 for 3 equal angles, we get 60 as the measure of each of these angles. And I'm only writing it on these sides for reasons. If I want to get a right triangle out of here, then I'm going to draw a line that divides that top angle into 2 equal angles of 30, splitting this bottom side into 2 equal parts with a right angle. So I'm defining my hypotenuses as 1 because that's going to be most helpful with our unit circle for which we're developing this now. So this is the hypotenuse of the right triangle. Of course, I could do it on this side, but we'll use this right triangle for now. So if I'm saying the length of this is 1, well, the full length here was also 1, which means that this length here must be 1/2. Well, now I have enough information once again to use my Pythagorean theorem. The side that I am missing here, I'll name A. And I have A squared plus 1/2 squared is equal to the hypotenuse 1 squared. So I have a squared plus 1/4 is equal to 1. Let's subtract 1/4 from both sides of this equation, and we get a squared is equal to 3/4, and we can take the square root. So we get a is equal to the square root of 3 over the square root of 4, which is just 2. So we have a side length of the square root of 3 over 2 for this side that we called A. Using this together with our SOHCAHTOA definitions, we can now find specifically sine and cosine for 30-degree, 60-degree, or 45-degree angles. So we'll look at how we do that in the next video.